This SMO problem back in 2010 taught me a little bit about the harmonic mean. I'd worked this kind of problem before, but I never really knew I was using the harmonic mean, and that was interesting to me. That was a learning experience for me. But what you have is a bicyclist, a cyclist traveling at 3 different rates of speed. This is uphill, horizontal, and downhill. And the lengths of each of the road types, the uphill distance is the same as the horizontal distance is the same as the downhill distance. But of course, the speeds are different, all right? And so you want to determine the average speed here. Now, it's tempting just to do what they call the arithmetic average, do 8 plus 12 plus 24 and divide by 3. But that doesn't work, and it's an easy mistake to fall into. The main reason that doesn't work is that the times required, like T sub 1 would be the uphill time, T sub 2 would be the horizontal time, and T sub 3 would be the downhill time. And oddly enough, you never have to know those to actually compute the average speed here. Now, it's well known that speed times time gives you distance, right? So these guys are all distances. 8 kilometers per hour times the time required to travel uphill would be a distance. Same for 12 and same for 24. But notice they tell you right here that they use the word length here, kind of an odd usage, distance really, but I guess it's just a manner of wording here. But they tell you right here that the length of each road type is the same. Okay, it's the same distance they're saying. The uphill distance is the same as the flat distance is the same as the downhill distance. And so what you get right here is actually, and I kind of skipped a little bit of a step right here, but each one of these guys is equal to L1, right? It's just happening at a different speed. That's L, this distance is L, and this distance is L, right? It's just, there's different times and different speeds, but it's given that this is a length, same length as this. All 3 of these lengths are the same. So that is why we have a 3L right here. And also, distance divided by speed is time as well. Like if you're going 50 miles an hour for 100 miles, it takes you 2 hours to do that, right? No, if you're going 100 miles, if you go up 100 miles at a rate of 50 miles an hour, it takes you 2 hours, 100 divided by 2, right? And so that means the distance divided by speed are units of time. So that's what happens here, and it's kind of interesting that the time just goes away. Notice the L's cancel nicely, multiply through or divide by L top and bottom. You get this statement right here. Now, how did I get to here? I multiplied top and bottom by 24. 24 times 3 is 72, and then this 24 over this 24 cancels to give you 1. 24 over 12 is 2, and then 24 over 8 is 3. So you get 72 divided by 6 is 12 kilometers per hour. Now, like a lot of people who enjoy math, I'll leave out the units until the very end, but it's not hard to verify. It's not hard to verify that that the units all cancel out nicely. And by the way, this is called the harmonic mean. And it is kind of interesting that you get the job done here without having to know the individual times. Okay, this is called the harmonic mean, and it's, if you think about it, it's reciprocal. It sort of looks like the normal mean that you're used to seeing. Harmonic mean. All right, again, if you reciprocated this, you would get 1 over 8 plus 1 over 12 plus 1 over 24 quantity, all divided by 3. So it's sort of the reciprocal of the arithmetic mean. I guess not quite, but the 3 would definitely be downstairs if you're taking the average of 3 quantities in an arithmetic sense. All right, let me know what you think.